In this lecture, we will learn to find the particular integral in a different method. This method is sometimes known as a method of variation of parameters, and in some books it is also written that is wronskian method to find the value of the particular integral. Suppose uh, it is a differential equation, second order linear differential equation, d square y by dx square plus b into dy by dx plus cy is equal to x, capital X. So capital X is a function of x which is in the right hand side of equation number 1. Now let the complementary function is a into y1 plus b into y2. So basically y1 and y2 are two solutions of this equation, and y1 and y2 satisfy d square y by dx square plus b into dy by dx plus cy is equal to 0. And this equation is satisfied by y1 and y2. And let us assume that the particular integral is u into y1 plus v into y2. So you look at this equation again. Capital X is in the right hand side, and this is a function of x. What is capital X? It is a function of x, and it is in the right side of the equation, and we are assuming that y1 and y2 are the solutions that satisfy d square y by dx square plus b dy by dx plus cy is equal to 0. And this is the complementary function. Form of the complementary function is a y1 plus b y2. A and b are constants, and let us assume the particular integral is in this form, u into y1 plus v into y2. Now we will calculate the values of u and v. So there is a derivation. I am just skipping this derivation. Let us focus on the formula. So the formula is, that is, u is equal to integration minus y to x. What is capital X? Capital X is in the right side of the equation. It is a function of x, and in the denominator y1 y2 prime minus y prime y2 dx. And what is b? B will be integration y1 x, and in the denominator y1 y2 prime minus y1 prime y2 into dx. So this is the formula to find u and v. So what are the steps to find the complementary function and particular integral? At first we have to find out the complementary function, which is a y1 plus b y2. This is the structure of the complementary function. A and b are constant. Next we will write that particular integral is u into y1 plus v into y2. Now what are u and v? U and v are given by this equation. Now you look at the function in the denominator y1 y2 prime minus y prime y2. This term is known as the wronskian. Y1 y2 prime minus y prime y2, and this term is known as the wronskian. So let us take an example. Suppose d square y by dx square plus y is equal to cosec x. So we can write this equation in this form, that is d square plus 1 into y is equal to cosec x. So at first let us find the auxiliary equation. So auxiliary equation is m square plus 1 is equal to 0. So m is equal to plus minus I. So in this way we can find the auxiliary equation. We know how to find the auxiliary equation. In the previous lecture we have already discussed how to find the auxiliary equation. So d square plus 1 into y is equal to cosec x. So writing m in place of d, we can write m square plus 1 is equal to 0. So m is equal to plus minus I. So this is imaginary. So comparing with the formula for the imaginary root, the complementary function will be a cos x plus b sin x. This is the formula. Here alpha is equal to 0 and beta is equal to 1. The standard form is m is equal to alpha plus minus I beta. So using that form, the complementary function is a cos x plus b sin x. So y1 is cos x. If we look at the complementary function here, a cos x plus b sin x, if you compare with the formula, that is a y1 plus b y2. So what is y1? y1 is equal to cos x. And what is y2? y2 is sin x, because we know the formula is a y1 plus b y2. So y1 is cos x and y2 is sin x. Now what is the formula for particular integral? This is u into y1 plus v into y2. u y1 plus v y2. What is u? U is equal to this one, this formula, and for v, this formula. Here what is x? X is cosec x. X means that is term in the right hand side, that is capital X. And next you have to find the wronskian. Wronskian means y1 y2 prime minus y1 prime y2. Now you know the value of y1, so you can find y1 prime. You know the value of y2, so you can calculate y2 prime. y2 prime is the differentiation of y2, means cos x. And what is y1 prime? y1 prime is the differentiation of cos x, means minus sin x. So now we will put all these values in the formula of u. So formula of u is this one, that is minus y2, capital X means cosec x dx, y1 y2 prime minus y1 prime y2. We have put those values here. So ultimately after some simplification we are obtaining this is minus integration dx means minus x. Similarly for v we can calculate v also. Let us substitute all the values here, and after substituting all these values and after simplification, this is integration of cot x dx means log of sin x. So we have found u and v. So now particular integral will be u y1 plus v y2. So these are u and v. y1 y2 already given here. So this is the value of the particular integral. So general solution is complementary function plus particular integral. So this is the form of the general solution. Let us take another example. Suppose d square y by dx square plus y is equal to tan x. So at first let us find the auxiliary equation. So writing d in place of d square y by dx square, the left hand side is d square plus 1. So d square plus 1 is equal to 0. So m square plus 1 is equal to 0. So m square equal to minus 1. So m is equal to plus minus I. So we know the formula of the complementary function when roots are imaginary. So y will be a cos x plus b sin x. So if y is equal to a cos x plus b sin x, then y1 will be cos x, y2 will be sin x. Then find the wronskian, y1 y2 prime minus y1 prime y2. This is 1. Now find the particular integral. Formula is u y1 plus v y2, where u is minus y2 divided by wronskian into capital X. Capital X means tan x. So this is u. So if you do the integration process, ultimately you will obtain this function. And for v, this is the formula. Again you proceed like this. So this is the value of the wronskian. Wronskian is 1. So ultimately you have to integrate cos x tan x dx and you will obtain minus cos x. So particular integral is u y1 plus v y2. You have calculated u, you have calculated v, you know the values of u1 and y1 and y2. So you can calculate the particular integral. So the complete solution is y is equal to complementary function, which is a cos x plus b sin x plus the value of the particular integral. So this is the particular integral. So this is the complete solution. So in this way, by the method of variation of parameters or the wronskian method, you can also calculate the particular integral in this way. So thank you all for listening the lecture.